So hi everyone and welcome back to the channel. Now I've been meaning to upload this engineering and bicycle related Q&A for ages. Instead of just listening to me blabber on in front of a camera, I thought I'd overlay some pretty cross-country mountain bike footage. So if you're into mountain biking, you might find it a bit more interesting. And if you're not, if you've got YouTube Premium, you can just turn the screen off and listen to this as more of a podcast. Anyway, without further ado, let's get into it. First question came in on YouTube from someone called MS. Thoughts on the design and use of aluminium stems in combination with carbon steerers and handlebars? Well, this is a bugbear of mine and has been for ages, and I've always said this. Not enough component manufacturers in terms of stems are chamfering the edges of the clamp. Whether that be the handlebar clamp or the steerer clamp, you see so many damaged carbon parts just after doing the bolts up because there's not a little chamfer or radius on the edges of the clamp. Now, on the CAD screen it might look perfect, but in reality you get small amounts of fretting, you get deformation when you clamp it up and when you put load on the carbon parts, and the edges do dig in and start to fret and eat away the carbon, which can be the initiator for kind of catastrophic failure of your handlebar or the steerer. So whenever I get a new aluminium stem, or if I'm inspecting one, I make sure the edges are rounded and nicely chamfered, so under any fretting or deformation there's no possibility for damage. And I urge you all to do the same, and I urge all manufacturers to start putting chamfers and radiuses on their engineering drawings, even if they probably don't have engineering drawings, because you know this is the bike industry. Is magnesium actually as good as a vibration damper as VAST claims it is compared to aluminium and carbon? Well, magnesium alloy does actually have about 7 times the amount of natural damping that a 6061 T6 aluminium would have. Now this is kind of difficult because the damping properties do change depending on how much load or how much stress is in the component. But if you take kind of it at a nominal low stress state, yes, magnesium alloys do have more inherent damping than most aluminiums, but probably less than carbon fibre epoxy, obviously depending on the layup and the load direction. However, damping coefficient of any metallic kind of instrument is so low, it's in fractions of a percent, that on a bicycle frame you're probably not going to feel any difference. That's my personal opinion. Your thoughts on triplet spoke lacing patterns for rear wheels, i.e. 2-to-1 spoke lacing, where you've got double the spokes on the drive side to the non-drive side? Well, I actually think it's a good thing, and it all comes down to the bracing angle given by the hub geometry. Now when you've got a cassette on the back, your bracing angle, your horizontal kind of bracing angle, your horizontal force component goes down because the spokes are much more straight down to the hub. They're not splayed out wide because you have to fit the cassette on. Now if you have an equal number of spokes on the drive side and the non-drive side, to balance the horizontal forces to dish the wheel in the centre of the frame, you would have to have very, very low spoke tensions in the non-drive side because their horizontal force component has a greater mechanical advantage, let's say, because of the direction of the spoke. So if you drop the number of spokes, you know, if you halve the number of spokes on the non-drive side, all those spoke tensions can be increased, therefore they're less likely to come loose, have higher, you know, structural integrity. So I do think the 2-to-1 spoke lacing is a good idea. That was from Richard on YouTube. Cheers for that.
Let's try and clear this techie section. Don't think I've done it before, but we'll find out. I'm clipped in, so that's good and bad. Tyres are very wet. Yep, we've done it. We've done it. Very stiff and uncontrolled, but
another interesting question from QwRTY. Do you believe the new 9200 and 8100 Shimano power meters have their issues sorted from the last generation? I can't say for sure, but they've definitely modified the main issue with those power meters, and that was the asymmetry of the crank. So if you look down the centre line of the crank, the old Dura-Ace and Ultegra shapes were asymmetric because they were more based around kind of artistic flair, and then a power meter was kind of bodged on as an afterthought. And the power meter never really worked because the strain gauges either side of the centre line were reading different things, and when you want to cancel out parasitics from the strain gauge, you need those gauges either side of the centre line to be reading opposite but equal magnitudes, and they never read opposite but equal magnitudes. They were opposite in terms of their sign, but the magnitudes were all over the place. So cancelling bending strains, axial strain, torsional strains on those strain gauges was problematic, which is why they always gave erroneous readings. The new ones look to have improved that. They are now, obviously Dura Ace and Ultegra is a symmetrical crank design, so those bending strains should be easier to cancel out. And they also, I think, have a proprietary gauge layout to minimise any parasitics from installation angle, incorrect installation angle of the gauges, because there's another gauge on the grid which I've seen. I can't remember where I saw the pictures leaked from, but there was a kind of a fifth gauge on each rosette, I think, which was placed at an angle, and that angle is obviously known to them, so it can kind of cancel out misinstallation angle. But that's just my belief. But I haven't tried one, haven't tested one, don't know.
Oh, fuck this. Nice to go. Right, I'm at the bike. This is a fucking disaster. I'm absolutely soaked through. I've fallen into a bog twice, and kind of need just to get out of this boggy area, but it's good fun. These bits are fine. It's just wet, shallow, but there's some hidden bogs where you just put the front wheel in, you're going over the bars because the mud is that deep. Right, let's try this. Who knows if this is going to be doable. Let's go for this rut. Oh, he's gone over the top of that rut. No idea. Oh, there's a bog.
Gary O'Sullivan. I'm a short person with very short legs, so I have a 50cm frame with only 90mm of exposed seat post, which is a 27.2 diameter. I find that combination really harsh and uncomfortable and unforgiving over bumps. Would you recommend a compliant seat post, i.e. the Ergon CF3 or Canyon kind of split seat post design? First of all, I probably wouldn't, because I don't think you can have enough seat posts sticking out for those kind of leaf spring designs to work. I would say there's not a lot you can do at the moment apart from fiddle with tyre pressure, but if you're that short, I would recommend going to a much smaller frame size, so even trying a 46 or a 48cm on your next bike. And actually, if you think about it properly, you probably can look at women geometry bikes as well. So in Giant, that would be the kind of live range of TCRs. They're women's specific geometry, a very, very sloping top tube. They expose more seat posts for shorter riders, and they actually tune the carbon layup to give a much more comfortable ride for lighter and shorter riders with probably less power output or torque output. So, you know, if you're a guy, you might get a bit of ribbing on the local club ride, but if you can say, well, actually, I've picked this bike because it fits me and it actually is comfortable for me, then why not go for the Liv TCR or the Liv Langmuir or whatever they call it these days? Question here from someone called Rollings. Rolling resistance or aerodynamics in wheel and tyre setup? I ride mostly flat, short, steep, punchy climbs at a whopping 27 kph average. I would say go for the rolling resistance and comfort setup over the deep aerodynamic setup. At that speed, I would say pick the kind of shallow, lightweight rim section that's going to feel nicer. It's going to feel a bit more exciting to ride. Anything north, if your average is about 35, I would say you definitely need to focus on aero a bit more. But at your speeds, I would say rolling resistance, comfort, and you know, just having a nice feeling bike is more important.
My black beauties. My black beauties. Alright, I'm on the climb for the second time. One more lap, one more downhill. Let's see if we can get clipped in, first of all, and clear this section again. Because we did it last time. It was actually alright. No, 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 no. Did not. The problem is I can't get bloody right foot out when I'm clipped in. Fuck it.
Question from LEG. What are your thoughts on budget ballpark $500 US carbon wheels? Well, you can't really get that many good ones these days for $500 US, if I'm not mistaken. I mean, I remember when I used to buy Fast Sport rims, when I used to build my own wheels, and buy hubs on closeout and clearance deals and try and find cheap spokes, cheap SAPM CX4A spokes to build them up with. My target figure was 500 USD, but off the peg I think you might struggle with that these days. Your best bet is probably something like the Lun range, the kind of entry-level Lun range that Windspace do. You've got kind of proven reliability with those and proven customer support and warranty and everything, so check those out. Question from Mitch Riley: how do you clean, maintain carbon rim brake tracks to extend the life and reduce squealing? Good question. There's not a lot you can do. Make sure the rim is clean after a wet ride, and make sure the pads are really clean after a wet, kind of gritty ride. So get a toothpick, clean the grit out of the grooves on the pads if there are any grooves in the pads. You could give the pads a little sand, a light sanding, just to take off the... Sometimes I find the rubber pads for carbon rims, they kind of glaze over the top surface and can go quite hard, and they can even transfer some of the epoxy from the rim onto the pad. So give those a light little sanding now and again, pick some grit out of the grooves. And to reduce squealing, you want to obviously make sure that basically you want the back of the brake pad to contact the rim first, and then as you compress the lever more, then the front or the leading edge of the brake pad will then fold in, but that will reduce any squealing and vibration induced into the caliper. Assaulted Peanut, can we get some comments on the cycling team DSM's on-the-fly tyre pressure adjustment that they were going to use in Paris-Roubaix? Now, if you don't know about this, Scott and DSM had pioneered this kind of radical on-the-hub tyre compressor to change tyre pressure on the fly for Paris-Roubaix, and I actually thought it was a really good idea, but they didn't use it in the end because I think the riders protested a bit that it was too complicated and too heavy. But if you think about the engineering problem of riding on cobbles versus riding on predominantly in that race it's smooth tarmac, I mean your change in tyre pressure is huge. And all the riders, from day dot have just used the compromise for both, and that's really, well, it is a compromise. It's not good for the cobbles and it's not good for the smooth tarmac, and there's a lot of smooth tarmac on Paris-Roubaix. Most of the race is smooth tarmac, let's not forget. So why have the same tyre pressure and compromise for both? Now if you can adjust that tyre pressure on the fly, you would, wouldn't you? So I actually thought it was a really good kind of an ingenious solution to it. I don't really know the ins and outs of the technology, whether it's reliable or not, but the shame is it'll never take off as a product, but as an engineering kind of prototype for a one-off, because it's so niche, I don't think it'll take off as a product. But for a one-off race, if it's a kind of prototype, I think it was really cool. It's a shame they didn't use it, because I think the cobble tyre pressure is so much lower than you need for reducing rolling resistance on the smooth tarmac. If you had a race that was all cobbles versus a race that was all tarmac, are you telling me that you'd ride the same pressure? No, of course you wouldn't. So if you could change it, why wouldn't you? But they just didn't use it in the end. Well, I hope you enjoyed that. I hope you enjoyed that as a little listen along and a little watch along. So do let me know if you've got any more questions down below, and we'll do another one of these. If you've got any recommendations for the backdrop next time, let me know. And don't forget to like, subscribe, because it really helps out the channel. Cheers, I'll see you in the next one.